Welcome to your Algebra 2 lesson 9.1, 9.2. Today we're going to talk about distance, midpoint, and we're going to revisit parabolas. So our objectives for today are you will find the length and the midpoint of a line segment and we'll graph and write equations of parabolas. If you will recall, the distance formula is as follows. The distance d between 2 points, x1, y1, and x2, y2 is d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the difference of the x's squared plus the difference of the y squared, then you take the square root of it. All right, let's look at an example. What is the distance between -3, 5 and 4, -1? So we're going to assign -3, 5 to be x1, y1, and 4, -1 to be x2, y2, and then we're going to apply our formula. So we write it down, and we'll plug in our values. Okay, so our distance for this particular problem is going to be d equals the square root of 4 minus -3 squared plus the difference -1 minus 5 squared, and then we're going to take the square root of the whole thing, and so we get square root of 49 because 4 minus -3 is 7, the same as 4 plus 3. 7 squared is 49. -1 minus 5 is -6. Inside the parentheses there is squared, and so -6 times -6 is positive 36. 49 plus 36 is 85, so we have square root of 85, and that gives us answer choice C. All right, now let's find the midpoint. A line segment's midpoint is equidistant from the segment's endpoints. It's in the middle. The midpoint formula describes the midpoint of a line segment joining point A, x1, y1, and B, x2, y2 as follows. The midpoint is x1 plus x2 over 2, so the sum of the x's over 2, y1 plus y2 over 2. In words, each coordinate of M is the mean of the corresponding coordinates of A and B, the mean or the average. So your x coordinate of your midpoint is the average of the x values, and your y coordinate of the midpoint is the average of the y values. All right. So we're going to find the midpoint of the line segment joining -5, 1 and -1, 6. Okay, so we're going to let x1, y1 be -5, 1. x2, y2 is going to be -1, 6. We're going to use our little formula there where we do the sum of the x's over 2, sum of the y's over 2. And so we get -5 plus -1 over 2, and then 1 plus 6 over 2. -5 plus -1 is -6 over 2, gives us -3. 1 plus 6 is 7 over 2, and that gives us 7/2. With fractions, we reduce them, but you can leave them as improper fractions. Okay, so now we're going to move on to parabolas. And we're looking at parabolas as a conic section. So we're going to be looking at something we've done before, but just kind of from a different angle. A parabola is the set of all points in a plane, so they're two-dimensional, we're in a plane, such that each point is equidistant from a point called the focus and a line called the directrix. So for every parabola, there is a focus and a directrix where you pick any point on the parabola. So any point on this gray curve here, the distance from the focus and the distance to the directrix are going to be equal to each other. Okay, now on this picture we show one particular point xy where that's true, but it's true for every single point on the parabola. No matter which point we pick, the distance from that point to the focus is going to equal the distance from that point to the directrix. There's two basic types, which then break down into 4 types of parabolas. There's vertical and there's horizontal. Vertical parabolas either open up, they're smiling at you, or they open down and they're frowning at you. Now these are the same type that we've studied before. Okay, they're functions. You can write them in y equals ax squared plus bx plus C form. We're going to write them in a little different form today, but you can write them in that form. The other big group are the horizontal parabolas, and they open to the right or to the left. And these are our horizontal parabolas, and they are not functions because they fail the vertical line test. Okay, today we're just going to be looking at parabolas that have a vertex at the origin, and that's going to make our life a little easier than it could be if we allowed the vertex to be anywhere. The standard form of the equation of a parabola with vertexes 0, 0 is as follows. Okay, we've got our two cases. This first one here where it has a vertical axis of symmetry, that also means it's a vertical parabola. It's either going to open up or down. And then the second one with the horizontal axis of symmetry means that the whole thing's going to be horizontal. It's either going to open to the left or to the right. Okay, so the standard equation of a parabola when we're focused on the vertex and the vertex is at 0, 0 is going to be written as x squared equals 4py. Your focus will always be at 0p. The directrix will always be the horizontal line y equals negative p. Your axis of symmetry is vertical, and it's the line x equals 0, which is actually your y-axis. For the horizontal parabolas, their equation is going to be written in the form y squared equals 4x. The focus will be p0. The directrix will be the vertical line x equals negative p, and you will have a horizontal axis of symmetry y equals 0, which is actually the axis. Okay, we're going to graph x equals 1/8 y squared. And we're going to identify the focus, directrix, and axis of symmetry. So we want to write it in the correct form. And today, the correct form is going to be y equals 4px, or it's going to be x squared equals 4py. Since we have a y squared in this problem, y squared equals 4px is going to be our standard form. Okay, so we want to isolate y squared. So we're going to multiply both sides by negative 8, and we get negative 8x equals y squared. Now, that means y squared equals negative 8x. So that would be the standard form. Now we're going to solve for, we know that y squared equals 4px. Our particular equation that we're working with today is y squared equals negative 8x. That means that 4p equals negative 8, so p equals negative 2. Just divide both sides by 4 and you're done there. Okay, so we're going to identify the focus, directrix, and axis of symmetry. So the equation has the form y squared equals 4px, which means we have a horizontal parabola. So that means the focus is at p0. So for this particular parabola, it's at negative 2, 0. The directrix is x equals negative p, so in this case it's x equals negative 2, so x equals 2. Because y is squared, just so you know y, the axis of symmetry is the x-axis, which is the line y equals 0. Okay, you don't have to write out the because y is squared part, but that's why we have an axis of symmetry. Okay, we're going to draw the parabola by making a table of values and plotting the points. Now, for all of these, we know 0, 0 is going to be on our parabola. If you will generate 4 other points, that should be enough to be able to draw on your parabola, as long as you take care to make sure that 2 are on one side of the parabola and 2 are on the other side. In this case, because p is less than 0, we're going to have a left opening parabola. So we're going to use negative x values. If p were greater than 0, it would open to the right for a horizontal parabola, and so we would use positive x values. And when it opens up or down, you are going to be able to use negative and positive. Okay, so we're going to use some negative x values. Now, your book kind of went overboard here, the makers of your book, and they found a whole bunch of points. All right, so they plugged in -1 for x, and so that gave y squared equals 8, so you take the square root of both sides and you get plus or minus square root of 8 or plus or minus 2.83. Then they plugged in negative 2. Well, negative 2 times negative 8 is 16. Y squared equals 16, so you do the square root, so you get plus or minus 4, and so on. And that created just a whole bunch of points. So, for instance, right here we have the point negative 1, 2.83, negative 1, negative 2.83. Here we've got the point negative 2, 4, negative 2, negative 4. So each one of these actually represents 2 points. So when you go to plot this, you've got a whole bunch of points. Okay, so here's our vertex at 0, 0. And here are our points that we found as we go across. And here's our parabola. Please notice that the focus is also on here. I want you to label the focus with an F so that I know that you know that that's the focus. I want you to label the vertex with a V. And then here's the directrix. Go ahead and label that. Okay. Our last example, we're going to write an equation of the parabola shown. All right, this is looking at it, I can tell this is a vertical parabola because it opens up. I also know P is going to be greater than 0 because it opens up. If it opens down, then P is less than 0. Okay. So when you have a vertical parabola, positive P means it opens up, negative P means it opens down. When you have a horizontal parabola, positive P means it opens to the right. Negative P means it opens to the left. Okay, so let's write this equation. All right, the graph shows that the vertex is 0, 0, and the directrix is y equals negative P. So what is the directrix? At first you might think it's at negative 3, but be careful. Look, it took 2 units to get us to 1. And so that means each this graph is scaled so that each marking is for a half unit. So when we get the equation of our directrix, we need to be careful of that. So we've got negative 1 half, negative 2 halves, which is negative 1, negative 3 halves. Okay. So if we know y equals negative 3 halves is the directrix, then we know negative p equals negative 3 halves, so p equals 3 halves. Okay, so since this opens up, it's a vertical parabola, like I said, so we look at our little table and see that the equation is x squared equals 4py. So we're going to substitute in 3 halves for p. Again, if negative p equals negative 3 halves, positive 3 halves equals p. So x squared is going to equal 4 times 3 halves times y. We're going to simplify. 4 times 3 is 12, over 2 is 6, so x squared equals 6y. And that's our equation. Okay, guys, that's it for today. Make sure you can do those problems to try on your own. If you cannot do them, remember that means you either need to rewatch the video or you need to come in and get some help because you want to have those done when you get to class so that you're able to get started on your rounds as soon as possible. Okay, guys, I hope you have a great day. Come see me if you need help. I'll see you in class soon.